Hi guys, hope everybody's doing great. My name is Ernest. So today we are going to look at one of the topics in mathematics. Of course, we have done an introductory part of this specific topic in our first video where we were trying to find and elaborate on the concept of errors. So today we're going to look at the second part, which basically will deal with different types of errors, and we can be able to, from this particular definition, define different types of errors and try to see how they come about. So mainly also we are going to look at some of the ways in which we can minimize these errors, and some of the, we'll wrap up with some of the applications that we had already mentioned in first video in order to appreciate this particular topic. So without further ado, thank you and welcome. So as I've mentioned, today's discussion is basically going to be the concept of types of errors. And as I mentioned from our first discussion on the concept of errors, we said that an error can be defined as a deviation from the measurement which has got a deviation from the true value. And basically, just write here errors. So we are going to look at types of errors. And there are different types of causes of these specific errors and how we can be able to minimize them. So first we looked at the specific applications of these errors in general. And for us to appreciate this specific topic in an essence, I'm going to just put this one in summary. We said that errors are going to assist us to ensure that the data that we are taking has got accuracy, reliable, or reliability, and we are able to, of course, try to have some kind of efficiency in the systems that we are going to use, which basically relies on data. So these are different models, of course, which rely on data, then therefore we are able to ensure that there's accuracy, reliability, and efficiency. And then we said that secondly, errors are going to be applicable in facilitating validation of these specific physical laws, validation of physical laws, and verification, of course, which I said that most of them are going to be applicable, especially in the physical sciences and mathematics. So then we said that errors, the concept of errors is going to assist us in quantifying this aspect of uncertainty. So this is quantifying uncertainty. By trying to study or analyze this aspect of errors, we are able to quantify uncertainty. And then next, we see that it's going to assist in informing the development of algorithms. And we say, oh, this is the spellings, algorithms. And we said that these are instructions which are used to, of course, and they're largely applicable in computer applications. So therefore, the concept of studying errors and the error analysis is going to assist us in the development of these specific algorithms that we are mentioning. And then we said that this is going to be applicable also in supporting optimization efforts. Analysis of errors is going to assist in supporting optimization processes and aid in risk assessment, especially in areas which deal with the concept of commerce. So basically my virus. I hope it's legible from that end. So therefore, these are some of the applications that we had said from our first discussion about the concept of errors. And we said that since an error is a deviation from the true value, then therefore we have different types of errors which we are going to look into in our discussion for today. So basically, I'm going to go direct to the different types of errors that we're going to, of course, discuss in our discussion for today, which basically we shall refer to as classifications of errors or types of errors. So we have different types of errors depending on the nature of the error or what causes that specific error. So the first one that we're going to have is what we refer to as systematic errors. These are systematic errors. And then next we shall have what we call random errors. And then lastly, we shall discuss, of course, there are other categories, but these are the main classes of errors or types of errors that we're going to discuss or have in this specific discussion. And then lastly, we're going to look at the concept of gross errors. So therefore, these are the three categories. And as I said, of course, their type of classification depends on what specifically causes these particular errors. So in a nutshell, we're going to see that when we're trying to make measurements of quantities, it's going to be based on specific international fundamental standards. And we have come across this concept of standards in some of our discussions, which basically implies that measurements are subjected to specific conditions, which are agreed upon by a community of, or other community of scientists, and therefore they are known. And these are used as a reference points for other measurements which are taking place, which pertains to the similar quantities or elsewhere. So therefore, we have international fundamental standards, which are basically regarded as reference points for other standards which are going to be used. For instance, if we talk about the concept of trying to measure mass, therefore we have an international reference which is going to be used as a reference for measurement of mass in grams or kilograms, which we're going to see later. Or rather, we have discussed one of these concepts when we were trying to talk about measurements in one of our videos. I'm going to put a link of the description in our description box for these specific videos. So for that. So therefore, as we have said that other measurements are derived from these specific international fundamental standards, these are referred to as derived standards, and therefore are going to be, of course, obtained from this. Now, in this particular sense, we're going to see that the concept of errors is going to be developed from this specific point, because there will be a transfer of information from this specific kind of measurements which are used as a point of reference, which we have mentioned to be international fundamental standards, which are regarded to be perfect. So therefore, so I can put this one in quotes. Perfect means that these are just true measurement, reference points for measurement. But as we're going to see later, in trying to obtain the perfect units, that is practically impossible. Therefore, as we transfer this information from the standard to the derived, of course, kind of standards, we're going to encounter some uncertainties. Basically, this stems. This gives a concept of trying to give or rather find the deviations from this specific standard measurement. So therefore, we're going to find that the concept of error is going to come from these specific quantities. So therefore, measurements that are made from this one are not going to be from the derived quantity, are not going to be 100% accurate. Therefore, it will result in inaccuracies. So next, we're going to look at some of how this particular concept that I've discussed here plays a role in these three specific types of errors that I've listed. And I'm going to use an illustration, of course, to try and figure out how this one is related. But before we look into that, we're going to look at the three specific errors that I've listed on the board and try to see how they come about. So the first one that I mentioned, of course, was systematic errors. And this basically refers to fixed errors, which of course will cause repeated readings by almost the same amount. But of course, we are going to see that the nature of these errors or the origin is specifically not known. So therefore, we're going to refer to them as systematic errors. So by definition, these are fixed errors, of course, which cause repeated readings, and therefore by almost as the same magnitude, but whose origin is basically unknown. So next, we are going to look at these random errors. So roughly, we can define random errors that errors which are caused by personal fluctuations, and in this case, we're going to look at this concept that I've mentioned about personal fluctuations, which of course are fluctuations of the apparatus or instruments that are used to perform this specific technique of measurement. So these are errors that result from apparatus, and of course all the instruments. Of course, we're going to look at there are specific causes or examples in order for us to understand, but roughly we can define random errors as personal fluctuations, of course, which can be able to result, for instance, from fluctuations in apparatus and instruments. And in some of the cases, we're going to see that there is going to be some instances where some issues like friction are going to be involved, which will result in this specific kind of errors that we refer to as random errors. So thirdly, we're going to look at the concept of gross errors. And the gross errors, as we can roughly say that these are errors that are caused by apparatus or instruments due to their makeup or construction. So therefore, we can say that it's the nature in which these specific instruments have been constructed is going to result in specific errors. So this is going to result in invalidation of the data that is under study. So therefore, we're going to look at some of the examples of these specific errors in order for us to understand what they basically are. So I'm going to just look at the individuals. As I've said, this was just a rough definition or trying to figure out what basically are these errors and what causes them. So I'm going to just have a look at the individual errors so that we can be able to exactly know what causes them and how we can be able to describe them. So first we're going to look at gross errors. And as we have mentioned, these are errors that is caused by, or others we can say a poorly constructed instrument. And next, this kind of errors can result from mistakes in using this specific instrument. So mistakes made in using the instrument. An instrument, in this case, I refer to the instrument that is being used to perform the measurement. And then the mistake that can be made during recording of data. And then we are going to see, among others, that calculation of this specific data, or trying to analyze this specific data, calculation of a result, that is, rather calculation of the data and finding results in this specific measurements. In the process, we are going to find out that there can be a chance for making of these specific errors. For instance, if I am making a reading of a specific mass, or rather something that is being measured on a scale, and then the reading is indicating as 1.01 kilograms. If I read this one as 1.10 kilograms, this mistake will be, of course, as a result of the second factor that I've mentioned here in mistake in using the instrument. I'm trying to use the instrument wrongly, or maybe perhaps trying to record the data in a way in which it is inaccurate from the specific reading that is being shown on the instrument. So therefore, this will result in what we call gross error. Or sometimes, if we try to look at some of the causes in using the instrument, still we can find that if I try to memorize a reading that is taken from an instrument, perhaps if it is indicating 3.21 kilograms, and if I wait for a specific amount of time and try to memorize this reading, there is a chance of me writing 3.12 kilograms, which will of course result in what we refer to as a gross error. So these are some of the ways in which this type of error can be able to be, of course, obtained. And we're going to look at in a summary on how we can be able to, of course, try to correct this specific error. So in this case, of course, we're going to see that roughly we can say that if we obtain an instrument that has got a specific qualification for its efficiency, then we're going to minimize this kind of error. And then number two, if you are going to be keen enough in order to make the correct reading from the data and in the recording, and perhaps calculating the results as per the appropriate procedure that is being requested of us, then we're going to minimize this kind of data. And lastly, if we try to indicate the readings or the data that we obtain at that specific point instead of trying to memorize it, then we're going to minimize this type of data. This type of error that we call gross errors. So next we're going to look at a second part of the errors that I mentioned, which basically, sorry for that, is systematic errors. And for systematic errors, from our initial definition, we said that these are fixed errors which will cause repeated readings. And they, of course, have one of the characteristics is that they are roughly occur in a specific amount. So they are inherent errors. They are inherent errors of what we refer to as apparatus. So I can just give a summary of inherent errors of apparatus, and of course all the methods which is being employed in order to handle the specific data that has been measured. So therefore, systemic errors basically refer to inherent errors of apparatus or the method that has been used. And therefore, as we have said from our first opening statement on systematic errors, we say that they always give a constant deviation. And therefore, in any case, if we come across a specific deviation that is appearing in a constant way or an inherent errors, in a constant way, then we are going to see that it's going to fall under the class of systematic errors. So in this case, for systematic errors, we are going to look at reasons for systematic errors, or some of the causes of these systematic errors that we're mentioning. So one of them, we said that I can just do away with this part of what we have already written. I hope that we have understood these two specific concepts. That's a constant deviation, and then it involves inherent errors of apparatus, or the method which has been used. So I'm going to look in a quick way some of the reasons for these systematic errors. So basically, I'm going to look at the reasons. So the first one is construction of the scale. Now, as we said that these are inherent, basically inherent errors of apparatus or the method used. Construction of the scale of this particular instrument or apparatus, whereby we find that it's not uniform, or sometimes maybe not clear, therefore it's going to result in systematic errors. And then if we find that it's pointer, so some of the instruments that we use have got what we call pointers. So therefore, if the pointers are not straight, this is going to result in a wrong reading perhaps, and it's going to give a systematic error. And then we're going to see that the concept of parallax, it's going to play a role in trying to come about these systematic errors. Now in some instruments, we're going to see that this concept of parallax is going to be overcome with a mirror under the counter. So this is one of the ways that this concept of systematic errors are going to be, of course, overcome by placing a mirror under the counter for it to be read accurately. So lastly, we're going to see that the reasons for systematic errors is going to be observational. We can have an observational reason as to why these errors are going to occur, whereby we find that the skills of the observer are going to play a vital role in trying to come about these errors or not. So therefore, this is going to be referred to as observational errors. So we're going also to look at the last bit of these errors that we had looked into, and try to see how they can be able to be, of course, described. And our last part of it, that is number C, is going to be the concept of random errors. I'm just going to put it this way. This was number C. So for random errors, we're going to see a situation whereby after correction of other parameters, which are of course causing the systematic errors and the gross errors, we're going to see that still some errors are going to be encountered. And this is going to result from, of course, the individual who is taking the readings perhaps from the fatigue or external environment causes which are going to result in errors. And this can either be positive or negative deviations from the expected value. So therefore, these are going to be referred to as random errors. And these are going to be minimized by taking a large amount of readings, or taking many readings from the instruments, so that we're going to find the average and try to reduce this concept of errors. Now, I hope that we have understood how some of these aspects of errors come about. And from our next discussion, we're going to see that whenever we're going to treat different types of data, we're going to include the aspect of errors. And in case of need, I'm going to mention this specific video so that we can be able to do a reference. So in summary, we have said that the errors, study of errors are very important. Now, apart from the three types of errors that I've discussed, in addition to that, we're going to see that there are other errors which we're going to encounter, of course, which fall under the minor categories of these major ones that we have discussed for gross, systematic, and random errors. So that is it for today, guys. I hope that you have gotten a concept on these three types of errors, and we're going to apply it appropriately in case we come across it in our discussions. So thank you. That is it for today. Bye. God bless you.